Greetings, Mindsetters. You're here with me, Megan. Welcome, grade 11s, to today's maths show. Today we have special revision lessons on exponents and surds and equations and inequalities prepared for you. We'll be selecting highlights from the lessons shown early in the term to help you revise for your end of term tests. You can download the notes for today's show on learnextra.co.za/live.
Let's have a look and see what would happen if we gave you an example that looked like this, okay? The key difference here is that in this case, the terms are not all being multiplied together. I'm sure you can quite clearly see that I've got a minus separating the terms in the numerator, and I've got a plus separating my terms in the denominator, okay? So the main law, the main thing that we may not do, all right, I'm sure you've heard your teacher say it 100 times, is that you may not cancel over a plus or a minus sign, okay? So a major no-no would be canceling those, for instance. We are not allowed to do that, okay? So please watch out. Again, it happens that people sometimes think that that's what we can do, but please no. All right, so make a note next to your sheet here. If you're writing this down, please make a note that you cannot cancel over a plus or a minus. So what do we do? All right, what we need to remember is that if there is terms being separated by pluses or minuses, factorize them, okay? And in this case, the way we're going to factorize them is we're going to look for a highest common factor. That's what our goal is over here. Okay, right, let's start with this though, guys. I've got an x plus 1, so I've got a double exponent over there. So just to make my highest common factor a little bit more clear, what I'm going to do is I'm going to split that and write it as x to the 5 times by x to the 1. And I'm going to do the same over here, x to the 5 times by 5 to the negative 1. All right, so I've just separated the bases with their exponents. And let's do the same down below here. So I've got a 5 to the x and a 5 to the 1 plus 5 to the x. All right, hopefully we can all very clearly see that in the numerator, I've got a common factor of 5 to the x, and in the denominator, I also have a highest common factor of 5 to the x, okay? So let's take that out. If I've got 5 to the x, which comes out of my numerator, what we are left with is 5 to the 1 minus 5 to the negative 1. And down below here, again, if I take out my 5 to the x, what we are left with is 5 to the 1 plus, and if the whole term of 5 to the x comes out, remember what you're left with inside your bracket is a value of 1. Okay, so the whole term of 5 to the x has come out, and we were left with that 1 over there. Okay, so now, because we've now created a multiplication sign between the 5x and the bracket, now we are allowed to cancel them. Okay, so this is where those will cancel each other out, which really gets rid of the problem of the x and the exponent, hey? So what are we left with? I'm left with a 5 minus. Now just remember that 5 to the negative 1 is going to be the same as 1/5. Okay, and I'm left with 5 plus 1, which is going to be 6. So let's see over here. We're going to have to just do a little bit of a fraction here where we add our fractions, which is going to become 25 minus 1 all over an LCD of 5. And instead of dividing by 6, we all remember the method of tipping and timesing. I'm going to multiply it by 1 over 6. Okay. 25 minus 1 leaves us with 24 over 5 times by 1 over 6, where my 6 will cancel with my 24 4 times, and we are left with 4 over 5. Okay, so the key difference is that in the previous examples, we had all of our terms multiplied together, whereas in this example, because of that plus and that minus, we were not allowed to cancel over anything, so therefore we had to take out the highest common factor, and by doing that, we were allowed to cancel. Okay, right. Just to make sure we get the message home, I want to do one more of those examples, okay? Right, guys, similar story. You can all see the same format here. We've got our expression with exponents in it, and we are separating, the numerator has got terms separated by a plus. Okay, so when you see that, I really do want you to try and remember that that's what we're looking for. Okay, try and take out a highest common factor and see if that works, if that helps us to cancel it. Our double base of 3 to the x plus 2, let's start by separating that. So I've got 2 multiplied by 3 to the x times by 3 to the 2. I've got a plus, and then I've got 3 to the x times by 3 to the negative 3. Okay, so we can see what I've done there. I've just simply split the bases and given them each their own exponent. And 3 to the x times by 3 to the negative 2. Okay, so once again, having done that, now the next thing to do is to identify that common factor. And it's generally the one where we have an exponent with an x in it. That's the one that we want to take out as our common factor. So, doing that, if I've got 3 to the x, let's put our equal signs here, that's going to leave us with 2 times by 3 squared plus 3 to the negative 3, and we're sitting at everything over 5 times by 3 to the x times by 3 to the negative 2. Okay? And those will cancel each other out. Okay, so we can all see how that works. 2 times by 3 squared, which is 9, so 2 times 9 is 18. This is going to be 1 over 27. Okay, and down below here, I've got 5 times by, and basically that's 1 over 9. Okay. Right, finally we'd have to find an LCD, and we would have to find an LCD of 27 and an LCD of 9. Okay. At this stage, I don't have my calculator up on the screen, so I'm not going to, I'll leave you guys to finish that one off for me. Just remember, if you find the LCD of 27, what you do to the bottom, you do to the top, so you're going to take 18 times 27. And then, once you've simplified the denominator, just remember that you have to tip and times it to simplify. Okay, so you should all manage to finish that one off on your own. Okay. Right, so we've had a look at just basic expressions with exponents and simplifying it. We've had a look at the laws and how we use those. Then we've had a look at expressions where we are either multiplying our bases with exponents or where we're adding and subtracting. And the adding and the subtracting, remember, we've got to try and factorize it first before you can do any simplifying. All right, so that brings us to the next part of our exponents, which we did deal with a little bit last year, which is our exponential equations, okay? Just like any equation, an exponential equation, we're finding the value of the variable. So we'll be solving for x or whatever the variable happens to be, okay? So what I want to do first is let's just take a look at a basic one of the ones that you really would do right in the beginning of grade 10, just to refresh our memories as to how we go about doing this. If I have got 2 to the power of x, which is equal to 16, remember the idea, guys, is that you want to get the base on either side of your equal sign to be the same, all right? If we can do that, once the bases are the same, we can drop the bases and we make the exponents equal to each other. So if I have got 2 to the x is equal to, instead of writing it as 16, let's again prime factorize the base, which is going to be 2 to the power of 4. Sorry. 2 to the power of 4. Okay. Right, so having done that, we can all remember now when those two bases are the same, that would mean, therefore, that my value for x is equal to just 4. Okay, so we all remember how that works. Okay, let's then see if we can apply it to one that's a little bit more tricky. And what we've got over here, this time, is 5 times by 2 to the x minus 3, and this is now equal to 80. Okay, just watch out for order of operations here. Bear in mind that that x minus 3 is only being applied to the base of 2. Okay, so would I be trying to sort of get 80 down to a base of 2? Not yet, because what we actually need to do first is get rid of our 5. Okay, so we're going to divide 80 by 5. And if I've got 2 to the x minus 3, which is equal to 80 divided by 5 leaves us with 16. Okay, so it actually gets us back to a very similar place to what we were in the previous example, because if I've got 16, that's going to then be written as, again, in its prime bases, 2 to the power of 4. And if we simplify that, we can then drop our bases, and our exponent of x minus 3 is equal to the exponent of 4. And we can then just solve it normally, where 3 will come over to join 4, and we land up with 7. Okay. Right, grade 11s, I hope you guys remember that from last year. And what I would really suggest is, although you guys have probably gone on to ones a lot more complicated than that, go back to your grade 10 work and revise those, because this is important to remember, and it can also start getting a little bit involved and tricky, and it's always good to go and practice. Right, grade 11s, now let's look at an example of an exponential equation that's just a little bit more on the difficult side. What we have over here is now not just one term on the left-hand side and on the right-hand side, but in fact 2 terms, all right? We've got our 2 to the 2x plus 1 minus 2x, which is equal to 8. Taking our minds back for a minute to the example we did earlier, where the terms were separated with pluses and minuses, let's think about what we did, and that was that we factorized. And that's exactly the route I want you guys to take here as well. If I've got 2 to the 2x, what again we can do is, if it helps you, well, it just helps to make it clear, is to separate the bases and write them each with their own exponents, and 2 to the x, which is equal to 8. Okay, so once again, there is a highest common factor of 2 to the x, okay? And taking that out is going to leave you with 2 minus 1, which is equal to 8. Okay, so everyone can see what I've done over there. Terms separated by plus or minus, look and see if we can factorize that term, okay? Now, 2 minus 1 is obviously left us with just 1, and that's equal to 8. Now, the idea would be that we need to divide 8 by the value multiplied to the 2 to the x, but 8 divided by 1 is not going to make much difference. It's going to stay 8. So we've got 2 to the x, which is equal to 8, okay? And if I prime factorize, I'm going to say 2 to the 3, so therefore my value for x is going to be equal to 3. Okay, right, easy enough. I know you guys are going to recognize that in your tests now.
Let's go to a short break now. Remember, if you are struggling and you need help, remember to post your comments and questions on our Facebook page, facebook.com/LearnExtra, or on Twitter @LearnExtra. Don't go away. We'll be right back. Welcome back, guys. Let's get into some more revision. Over to you.
Okay, now let's look at one that maybe is a little bit more involved. Okay, at the very start of it, I can't see any x squareds. Okay, so at the moment, it doesn't really, as I say, there's no x squared, so it might not be a quadratic equation. But what we are going to have to do is start off by getting rid of those brackets. We need to tidy up. And by tidying up, we're going to find that we'll probably get some x squareds involved here. All right, first things first, we are going to distribute into my bracket to get rid of my bracket on this side. And I'm going to have to FOIL my 2 binomials on that side of my equal sign. All right, so therefore, we are going to get 2x squared minus 2x plus 3 is equal to, now when we FOIL out our brackets, I'm going to get x squared. When I do my outers, so when we do our outers, I get negative 4x. And when I do my inners, I get negative 2x. So together, negative 4 and negative 2 give us negative 6x. And when we do our last, negative 2 times by negative 4 is going to give us positive 8. Okay, so step 1 dealt with. We've now gotten rid of our brackets, and you can see now that we've got x squareds in our equation. So it looks like we've got a quadratic equation to deal with. Let's gather all our terms to the left-hand side. Let's bring everything on that side. Let's get our right-hand side equal to 0. So doing that, I'm going to have 2x squared minus 2x plus 3. I'm then going to have minus x squared plus 6x minus 8, which is equal to 0. Okay, let's just add up like terms here. I've got a 2x squared minus a 1x squared, which is going to leave us with just x squared. I have got a negative 2x plus 6x, which is going to give us positive 4x. And I have got a positive 3 minus 8, which is going to leave us with negative 5. And it's equal to 0. Right, so we've got a quadratic equation. Because we've got our x squared, all of our terms are on the left-hand side. Right-hand side is equal to 0. We're all set up to now just finally solve our equation. Okay, so let's factorize. The reason why this trinomial is a nice easy one to factorize is because there's actually just a coefficient of 1 in front of my x squared. If there's anything other than 1, it makes that trinomial just slightly more complicated to factorize, but I'm sure by now your teacher's given you a nice method that you can work with in order to do that. Okay, so factors of x squared is obviously just x, and factors of 5, we're working with just 5 and 1. In order to get my signs right, my 5 will have to be positive and my 1 will have to be negative. So therefore, to solve for x, we have got x which is equal to negative 5, or we've got x which is equal to 1. Okay, and again, those are the two roots of your equation. All right. I hope so far so good. You guys are all following us. Completing the square. I'm sure you guys by now have done this in class. Sure you're all finding it easy, but let's just go through the methods and see. As I'm sure, again, your teacher has really made clear to you, is completing the square is quite a step-by-step logical process. So the thing with this is that you just have to practice it. And genuinely, if you practice the method, the questions all work out to be relatively easy to solve and to get into the completed the square format. Okay, so just practice it, guys. It's really one of those things you got to get under your belt, okay? Right, completing the square of this equation over here. The first thing we are going to have to do is I'm solving for x, all right? So let's take my whole number of 5 and I'm going to move it over my equal sign. So I'm going to say that x squared plus 10x is equal to negative 5, okay? If there was anything in front of your x squared, you would have to actually divide everything through by that value. But in this case, there is no number other than 1 in front of our x squared, so therefore I don't need to worry about dividing everything because anything divided by 1 is just itself, okay? So that step we don't need to worry about. Now we're going to do this. We're going to take the middle term. We're going to take our positive 10, and we are going to multiply that value by a half. And once we've done that, we are going to square it, okay? So therefore, what I'm going to have is 10 over 2. And 10 over 2 can obviously simplify to 5, and that's going to be squared. So we are sitting with 25, okay? And what we are going to do with that 25 is this. We've got x squared plus 10x. And we've got negative 5. Now you can see that I've left a gap there, and what I'm going to fill in that gap is this 25 that we have just solved for. What I do to the one side of an equation must be done to the other side. Okay, so therefore that's what we are now sitting with. And this side, the left-hand side of your equation, will now always be a perfect square. So when we factorize it, you want the two brackets to be the same. That's what you can expect. So we'll have x and x. The factors of 25 are going to be 5 and 5. Both of them need to be positive, okay? And on this side over here, negative 5 plus 25 is going to leave us with just 20. Okay, so instead of writing the bracket twice, let's rather say x plus 5 squared is equal to 20, okay? Next step, we need to now obviously solve for x. We're trying to get x on its own. So now it's a process of getting rid of the terms until x is sitting on its own. Okay, so squared is the next value we need to get, or next operation we need to get rid of. And the opposite of squaring is to square root. Okay, so I've got x plus 5, which is equal to, and if I square root 20, we are going to have the positive or the negative value of 20, all right? And finally, to get x completely on its own, I'm then going to move my 5 over, and I will have negative 5 plus or minus the square root of 20. bearing in mind that if you've got a surd, we can simplify those surds. Okay, so let's just actually do that quickly. I've got x which is equal to negative 5 plus or minus. The factors of 20, if I said 4 times 5, that's still equal to 20, except now 4 is a perfect square, all right? So what we can do is take the square root of 4 out of the bracket. So we've got our negative 5 plus or minus, and the square root of 4 is 2, but I'm going to have to leave root 5 as a surd because obviously we don't have a rational value for the square root of 5. So therefore, we're leaving our answer in this case in surd form. However, if your instruction in your test says to 2 decimal places, you're going to take it and type it into your calculator. And remember, if it says to 2 decimal places, it means to 2 decimal places. So please don't ignore that instruction. That's what they wanted to. Whatever the number of decimal places, please make sure you don't ignore that instruction. We follow what we're being asked to do. Okay.
Let's go to a short break now. Remember, if you are struggling and you need help, remember to post your comments and questions on our Facebook page, facebook.com/LearnExtra, or on Twitter @LearnExtra. Don't go away. We'll be right back. Welcome back, guys. Let's get into some more revision. Over to you.
All right, so let's have a look first of all at an example over here. When we talk about simultaneous equations, all right, if we were to actually, there's more than one way to solve it. And if we were to think about it in a graphical way, all right, in terms of a graph, simultaneous equations in terms of graphs represents where your 2 graphs intersect each other, okay? So for example, if I had a parabola and I had a straight line graph and I needed to work out where those 2 graphs intersect each other, that would be a case of solving a simultaneous equation. Okay, so therefore we can solve simultaneous equations in a graphical way, or we can solve them in an algebraic way where we actually do the calculations. So we're going to show you both, all right? So let's have a look at this example over here, and let's see how we can look at it in terms of solving it using graphs. Okay, they've told us over here to draw the graphs of y equals negative x squared plus 9, which, because it's an x squared, we all know by now is a parabola, and y equals 2x minus 1, which we all know by now is a straight line graph. And they've asked us to draw it on the same set of axes, and from your graphs determine the points where the 2 graphs intersect each other. Okay. Right, let's see. If I've got y equals negative x squared plus 9. Let's do a little bit of grade 10 revision for a second here. Remember your parabola. If you have got 9 in this term over here, remember that that represents your y-intercept, which in a case like this is also going to be your turning point, okay? So let's put our 9 over there on the y-axis. And to work out the 2 x-intercepts, we're going to let y equal 0. So I'm going to say negative x squared plus 9. I'm going to get rid of the negative, which makes it positive x squared minus 9. And I'm going to factorize. So we get x minus 3, x plus 3. And that gives me 2 x-intercepts, one being positive 3 and the other being negative 3. So on my graph, I'm going to put a positive 3 and I'm going to put a negative 3. Okay. All right, just so we don't run into space problems, I am just going to take that away so that we don't get ourselves confused. Okay, so the parabola, because it's a negative x squared, that negative over there is telling us that our shape of our parabola is going to be a negative frowning parabola. Okay. So we've got a y-intercept passing through 9, it's got an x-intercept through negative 3, and it's got an x-intercept through positive 3. And there's our parabola, more or less. Okay, it's not exact measurements at this point. And if you ask to do it, obviously the more accurate your measurements, the more accurate your answer is going to be. The straight line graph of y is equal to 2x minus 1. Okay, so that's going to have a y-intercept of negative 1. And a gradient of 2. So I'm just going to plot my gradient as a 2 over a 1. So therefore, my straight line is going to pass through there and down through there and all the way down. Okay. So I'm going to have to actually increase the length of my parabola and my straight line. and to make sure I get 2 points of intersection. The first being over here, and the second being over there. Should we change the color? So there's my 2 points of intersection. Okay, so reading it off the graph would then be a case of saying, okay, well, looking on the x-axis and looking on the y-axis, where do the graphs cross each other? So let's have a look here. If I take my line directly down from my point of intersection down to my x-axis and directly across to my y-axis, and if I do the same over here, I'm going to take it directly up to my x-axis and directly across to my y-axis, we're more or less going to be seeing that, okay, I can't tell exactly because I can see it doesn't fall on an exact number, but I can see more or less that the x coordinates over here are going to be somewhere around, I'm going to assume 2.5, 2.6 it looks like. And this over here, okay, we're going to have to take a guess, guys. We're going to have to prove it later, but it looks more or less plus minus 3. Okay, these are estimations at the moment. And down below here, okay, well, if that's negative 3, it looks something like negative 4, but we'll have to prove it in a minute. And down below here, yeah, it also looks quite low, so let's take a guess and say negative 9. So as you can see, the graph is not 100% accurate. It gives us an idea, but we're probably going to have to rely on algebra to actually prove it exactly. Okay, so now that we know what we're looking for, let's use algebra and let's actually prove it, and let's see how close our estimations actually are to the exact answers. To prove them simultaneously, we're going to take both equations. I'm going to take my y equals negative x squared plus 9, and I'm going to take my y equals 2x minus 1. I'm going to call that equation 1, and I'm going to call that equation 2. Now, this requires very little manipulating because on my left-hand side, my first equation is equal to just y, and on the second equation, the left-hand side, is also equal to y. So in each equation, if they're both equal to y on the left-hand side, what's on the right-hand side would then also have to equate to each other, all right? So basically what we're doing is we're essentially going to substitute the value of y from equation 1 into the value of y in equation 2, which means I'm going to have negative x squared plus 9 is equal to 2x minus 1. Okay, and can you see what we've done is we've actually managed to get rid of the y, and now what we're doing is solving for the x, okay, which helps. So now we've gotten rid of one of the variables. So let's solve for x here. We've got x squared, negative x squared. I'm going to bring my 2 over, which is going to be negative, and I've got 9, and if our 1 jumps over or comes to the other side, it becomes 10, and it's equal to 0. Okay, I'm going to divide through by a negative, which has the result of changing our signs. So I've got 2x minus 10 equals 0. And now what we would want to obviously try and do is factorize it. But if we look, we can see that it's not going to factorize. Factors of 10, 5, and 2, unfortunately, it's not going to get us to 2 in the middle there. So what do we have to rely on? I'm sure you remember from last week, if the trinomial doesn't factorize, use your quadratic formula. Okay, right, so quadratic formula, which is negative b. Now the b, guys, we know is the one in front of your x, so it's your 2, plus or minus the square root of b squared minus 4ac, which is negative 10, and it is all over 2a. Okay, while we're at this, I actually wanted to point out quite a nice little website for you guys to have a look at. Okay, if you've got some time and you're trying to solve these quadratic equations and you just need to check if your answers are correct, you guys can go and have a look at this website over here, if we can get to it. If we can't, you guys can write it down and have a look at it at home. Basically, it's really cool. It's a quadratic functions calculator. Okay, so it actually solves the quadratic equation for you. So I'm sure Kat's going to put that on the website.
I sure am.
And go and have a look at it. It's actually it's quite nice, and just to help you, give you a little bit of backup when you're solving quadratic equations and you just want to check your answer. Okay, so www.math.com. and then /students/calculators/source, and then finally /quadratic.htm. Okay, quite a mouthful of a website, but go and have a look at it. It's really useful. Okay, all right. But what I'm going to do very quickly is I'm also going to use the calculator. All right, so let's just put it into, let's use our calculator quickly to type in everything over here. So let's have a look. I've got negative 2. Let's start with our plus, the square root of 2 squared minus 4a, which is a 1, and b, which is a negative 10, and it is all over 2 times 1, which is 2. Okay, so we're getting a 2.316. So let's round it off to one decimal place, a 2.3. So my first answer for x is equal to 2.3. And let's just go back to our calculator for a second. Let's just replay our values. And all I'm going to do is replace the plus with the minus. Okay, and we get the other version, which is negative 4.3. Okay, so x equals negative 4.3. 4.3. Let's have a look and see how close we were to our previous answer. We said 2.6 over there, and we've landed up with 2.3. So we actually weren't too far off. We were pretty close. And the other value, we said negative 4. That was our estimation. The actual value was negative 4.3. So we can see the graphical method wasn't far off, but it wasn't 100% as exact as working it out algebraically. Okay. Right, so now that you've got the values for x, remember you do still need to work out the values for y. And this is the easy part, because all you have to do is take each value for x and sub it back into either equation 1 or equation 2. And let's be honest, we want to try and find the simplest way to an answer, so choose the simpler equation. Okay, I think we all agree the straight line graph was the simpler one, and that was the 2x minus 1 equation. So what we're going to do is we're going to substitute the first value for x, which was 2.3, and we'll work out our answer. Let's just move our calculator over. Okay, clear it. So we're going to say 2 multiplied by 2.3 minus 1, and that value was 3.6. Okay. So my y value is 3.6. So let's actually write that coordinate. So the x coordinate was 2.3, and the y was 3.6. And over here, I've got y equals 2 multiplied by negative 4.3 minus 1. Okay, so let's move it to this side. Let's clear that over here. So we're going to say 2 multiplied by negative 4.3 minus 1 equals, and negative 9.6. Negative 9.6. Okay, so the coordinates of that point of intersection was negative 4.3 and negative 9.6. Let's go back and see. Were we close? We had a 3 over here as my y-intercept, and we worked out that the 3.6 was the answer that we actually had in actual terms. And over here we had an estimated value of 9, and we got a negative of 9 at least, and we got an actual value of negative 9.6. So we can see once again we were pretty close. We weren't 100% exact on the graph, but that's why we need the substitute. That's why we need to solve a simultaneous equation by the substitution. Okay, so let's have another look at another simultaneous equation. It's such an important concept for you guys to know, and that's why it's really important that you understand it. Okay, once again, I've got two equations. I've got an x minus a 2y, which is equal to 0, and I've got an x squared minus a 2xy plus y squared, which is equal to 1. Okay. When you're working with a simultaneous equation, you're typically going to have one equation slightly simpler than the other, all right? So what I need you to do is look at the simpler equation, and then within that simpler equation, I want you to identify either the x or the y, or whichever the two variables are, the simpler one to get on its own, okay? So looking at it, I can see that I've got an x and a minus 2y. Now, I'm sure you guys agree it's going to be much easier to get x completely on its own. So therefore, what I'm going to do is I'm going to move 2y over my equal sign, in which case it will become positive 2y, and I've got plus 1. And we're going to label that equation 1. My other equation, the x squared minus 2xy plus y squared, which is equal to 1, we're going to label that equation 2. And once again, what we're going to do is we're going to substitute the x from equation 1 into the x's in equation 2, all right? So where I had an x over there and where I've got an x over there, we're going to substitute them with the value for x that we found in equation 1. So what we've got is, instead of x, okay, let's use our green to substitute. Instead of x, we have got 2y plus 1, which is being squared, minus 2. Instead of x, remember x is going to be 2y plus 1, and multiplied by another y plus y squared equals 1. Okay, so I hope you guys can very clearly see what I've done over there. I've just replaced every value for x with now this new value of 2y plus 1. Now it's a case of careful working out. Okay, now you've really got to just stay focused and don't make any silly mistakes. If we FOIL this out, we are going to land up with 4y squared plus 4y plus 1. Just be aware that this y and that 2 are both being multiplied to the bracket, so it's probably better to take the y away from the back of the bracket and just join it with your 2, just so it's clearer as to what's going into your bracket. So therefore, when we distribute, we're going to land up with negative 4y squared and negative 2y, okay? And then I've got a plus y squared, which is equal to 1. Okay, so now we just have to tidy up. So I've got a 4y squared minus a 4y squared, which will actually cancel each other out. And what are we left with? I've got a y squared, which is on its own now. I've got a 4y minus a 2y, which is going to leave us with just 2y. And I've got a 1 on the left-hand side, a 1 on the right-hand side. So when the 1 jumps over, it becomes negative 1 and it cancels out. So therefore, that's what we're left with. Okay, so now it looks a lot simpler. We're going to factorize it by taking out a highest common factor. So we're going to have our y plus 2, which is equal to 0, giving me two answers for y. I've got a 0 or I have got a negative 2. And finally, what do we have to do to find our x? We take our two answers for y and we substitute them back into either equation 1 or equation 2 to get the values for x.
Let's go to a short break now. Remember, if you are struggling and you need help, remember to post your comments and questions on our Facebook page, facebook.com/LearnExtra, or on Twitter @LearnExtra. Don't go away. We'll be right back. Welcome back, guys. Let's get into some more revision. Over to you.
We've had a look at determining the nature of roots. We've had a look at proving or showing the nature of roots. So the third type of nature of root question would then be to find the value of a missing variable if they actually give us the nature of the roots. Okay, so let's call this type 3. Okay, and type 3 is to find the value of a variable if the nature of root is actually given to us. Okay, all right, so let's have a look and see what we need to do here. They have said to us to determine the value or the values of p if the equation 2x squared minus 4x plus p is equal to 0, and they're telling us it has real roots. So the first thing we need to ask ourselves is, what do we know about delta if it has real roots? Okay, what we know is that it has to then be greater than 0. That's what we know about it, okay? They haven't specified anything in terms of rational or irrational, or equal or unequal. So I can't make any assumptions about it being a perfect square or about it being equal to 0. But what I can say with certainty is that my delta is greater than 0. It's positive, okay? So then the next thing we'd obviously have to do is work out the value of b squared minus 4ac. And we are going to make that greater than 0. So let's see, I've got negative 4, which is my value for b squared, minus 4a, and my c now is the value of p, okay? And it's greater than 0. All right, so what we can see we've got over here is an inequality. All right, so we're going to have to solve it as an inequality. So for negative 4 squared is 16. I'm going to get negative 8p, which is greater than 0. If I move over, I'm going to keep my negative 8p on the left. I'm going to move my 16 over. And I hope you're all sitting there thinking, I'm sure everyone's going to remember this. What is our rule when we divide an inequality by a negative? Okay, and the rule is that when we divide an inequality by a negative, my sign must change direction. Okay, we've taken the negative from the left to the right, so hence everything needs to actually turn around. Okay, so therefore our p is going to be equal to, or in this case, sorry, not equal to, less than 2. Okay. So therefore, what are the values for p that would make that quadratic equation real roots? Anything on your number line less than 2 would make it real. Okay, and with an inequality, we always typically represent it on a number line. So my values for p would have to be less than 2. Okay, so guys, when you're doing your nature of roots, remember your discriminants. Delta equals b squared minus 4ac. And once you've got your discriminant, you need to decide, are they asking me to just determine the nature of roots? Do they want you to actually prove the nature of roots? Or do they want you to find the value of a missing variable if they've actually told you the nature of the roots? Because knowing which path you're taking does influence the way you actually work the question out. But let's have a look at one that's maybe just a little bit more interesting. Let's say I've got this. I've got 2x squared minus 7x plus 3, and this time it's greater than or equal to 0. Okay, so let's just get rid of that. I need to now solve this quadratic inequality. Okay, first things first. As it stands at the moment, everything is already on the left-hand side. My right-hand side is already equal to 0. So if that's done, we don't have to worry about that. So remember, the next step is we had to factorize our left-hand side. So let's factorize it, and we're going to land up with a 2x and an x. We're looking for 7, so therefore we're going to have a 3 and a 1, where I get negative 6 and negative 1, which would get me my negative 7. Okay, remember from here we need your critical values, and my critical values are in this case positive 1/2 and 3, and I'm going to plot those on our number line. Okay, first things first, it would be 1/2 and 3. Okay, I'm going to use my parabola method just because it's that much quicker. If it was if this was a parabola, if I were to draw it, it would be a smiling parabola through the points of 1/2 and 3. And what I'm interested in this time is where they are greater than or equal to 0. So it's greater than or equal to 0, everything from negative infinity up to and including 1/2. And then from everything from and including 3 off to positive infinity. Okay, those are the positive portions of our graph. So therefore, what are my values for x? It's everything from, round bracket, from negative infinity to 1/2, and this time I'm going to make it a square bracket because we're wanting to indicate that it is included. And then we do our union sign. We show that there's a gap between the two of them, and then I say from 3 to positive infinity. Please watch out, grade 11s, when you're writing your interval notation, that it always gets written from smallest to biggest. So what do I mean? Please don't invert those and write that as 1/2 to negative infinity. If we think about that, that doesn't make sense. It must be written from lowest to smallest to biggest. Okay. All right, guys, so that is how we're solving our quadratic inequalities. And again, this also tends to creep into other sections as well. So you can't just put it in a box and isolate it into this quadratic section. You need to remember it so that later on, if it creeps up again, that you do actually remember to apply this method.
Well, guys, we've come to the end of today's show. Thanks for joining me. Remember to visit our website, learnextra.co.za/live, to get the notes and to watch the videos. And if you are stuck and you have any questions, send an email to helpdesk@learnextra.co.za and we will help you. Also, guys, we are dedicating the month of March to Library Month. Join us as we discuss some great books and some exciting competitions on the way. Goodbye.